First, we'll be looking at rocket launches. So, have you ever seen one on TV? Yeah, what was it like? Why don't you tell me a little about it? I don't know, what do you remember?
I don't really remember, but it goes really fast.
Okay, sure. Okay, let's move on. So, introduction to rockets. A rocket is a device that produces a strong force to push an object forward, like spacecrafts, missiles, or aircrafts. So, we'll be looking at Newton's third law of motion, which is that for every action, there's an equal and opposite reaction. And this is important in rocket launches because the force that it's using to push down the fossil fuel that's burning is pushing the rockets up in the air, like you can see in this picture over here. So rockets carry liquid or soil fuel that's burned in a chamber. This is mixed with oxygen and ignited or set on fire, which gives off the hot air that shoots out the back of the chamber and launches the rocket forward. So the propellants being burned creates an upward force, and this force is called a thrust. And this thrust pushes the rocket up, and it must be greater than the force of gravity that's pulling the rocket down, otherwise it won't get off the ground. So here's a fun fact that a rocket needs to travel at least 17,800 miles per hour to fly past the atmosphere to orbit the Earth, and at least 25,000 miles per hour to fly to other planets. So this is our first activity, and in this activity we'll learn how to simulate a rocket launch on a small scale and understand the physical mechanisms behind one. So for this activity we'll basically making a rocket out of balloons. So here is the materials that we're going to need. Give you a few minutes to gather all of this.
For the balloons, does it have to be a certain size?
No, any balloon will do.
Okay. the duct tape right now?
No, you can just have it. You can just have it like on the roll. You'll be using it later as you go.
I'm done.
Okay, great. So there will be pictures go along, but I have a sample, I guess, of what your finished product will be. I'll also be making it with you, like in case you need help. So the first step is to cut about 2 inches off the straw and tape that piece of the straw onto the balloon. And it's best to like blow up the balloon first so this tape sticks on properly.
What do we do next?
Next, you're going to want to cut off about another 6 inches of straw. It doesn't need to be 6 inches, it can be a little less. I just have 3 over here. And you're going to want to put that in the balloon and then tape it together really tightly. so once you have it done, you can give it like a test blow or something to make sure that the air stays in. Just you can let me know when you're done with each step. Are you done? Are you good? No.
Is it supposed to look like? Is it supposed to?
Yes, it's supposed to look like this. You have the straw on the top, and then you have the straw coming out. Okay. So the third step is to put some of the string through the straw on the top. Yeah, that's great. Okay. So step 4 is to get your paper, like, the little piece of paper you got before, and I want you to cut it into 3 triangles. So you have 3 right angle triangles over here. And then I'll show you how to tape it onto the side of the balloon once you've cut those triangles. Have your 3 triangles, and I want you to take one and bend a little bit of it back. Okay, so you have this little flap over here. You see this flap? You're going to take tape and you're going to cut up the tape into small pieces. And you're going to tape the flap. Put some tape on the flap. And you take the, you have the flap, put the tape on it. Then you take the end of the straw. And you stick it on like this. And then you fasten it. Like this. Yeah, that's great. And you can take more tape and then just secure it a little if you'd like. And I want you to do the same thing to the other two pieces. you should have left a little bit of space before the thing, before the, what do you call it, triangles of paper, but I guess it's fine. It just makes it easier to blow into when you have this little bit of space here, see? Why don't you try blowing into it and see if you can blow into it, and otherwise you can fix it. Okay, why don't you move them up a little? We can wait a few minutes. I don't know, why don't you try blowing into it? I just want to know that you are able to blow into the balloon successfully. Okay, see, where you have your triangles now is all the way up here, okay? I want you to push them down a little so you have a little bit of straw over here. So you can do this. Yeah, much better. So next up, you're gonna tape the string. You're gonna tape that string to your two chairs or walls or the table, really anything. That's as long as they're on different height levels. Now you can blow into your balloon and then, blow into the balloon from like the lower point. So you know how there are two levels? Place the balloon at whichever level is lower, and I want you to blow into it. Did you let it go? Did you like blow into the balloon and let it go?
No, we're just
yeah.
holding it.
Yeah, go ahead and let it go. Done. Yeah. You can count down and release the rocket. rockets and how it's being released. How are they related? Yeah.
The air pushes, the air is released and that pushes the balloon forward, but the opposite side.
Yeah, it pushes the balloon up, right? Because the air is going down. And that's exactly what the Newton's third law explains. So how is it similar to an actual rocket launch? What's like an actual rocket launch? What's different?
It's like an actual rocket launch because a rocket launches using the same way by pushing air and pushing the rocket forward using the air.
That's correct. It uses the same principles. So how's it different?
It's different because this is a balloon and that's a rocket.
It's different because there's a string guiding it. In an actual rocket, that guidance will be led from inside the rocket and not on the outside. So now we'll be doing Introduction to Gravity. So gravity is an invisible, attractive force that pulls objects towards each other. And gravity on Earth. So gravity pulls everything towards the center of the Earth, which is pretty much how we're not falling off the planet right now. And objects with more mass have more gravity. So basically, the bigger they are, the heavier they are, the more gravity they have. So the closer objects are together, the stronger the gravitational pull. So mass is how much matter an object has. So mass of an object will always stay constant, like no matter where you are. So common analogy for this is on Earth and on Moon, the weight will change, but the mass will always stay the same. So weight is the amount of force exerted on the mass by gravity, and weight can change from planet to planet. So gravity in space. Gravity keeps planets in orbit around the sun and the moon in orbit around the Earth. The high speed of planets in orbit is what keeps them from falling into the sun. Because if there wasn't any speed, the gravity of the sun would just keep on pulling them closer and eventually just envelop them. So spacecrafts and satellites travel around the Earth using gravity, and it's how astronauts float freely. So define gravity. So in this activity, we will learn about gravity and experiment with an object that's defying this concept. So it's basically going against gravity. So these are the materials you're going to need for this. Give you a few minutes to gather these. The black paper is basically just so you can see it better. I don't know, what color paper clips are you using?
Silver.
Okay. I'd say go with any dark colored paper. Well, I guess you could also just use the box itself. You don't really need it. It's just to make it easier to see.
I've got everything.
You have everything? Okay, that's great. So first step, if you're not using a shoebox, I want you to cut off the face of your box so it has a large opening, like a shoebox. Well, I am using a shoebox, so okay, that's great. So get the black paper, and if it doesn't fit, just cut it and then kind of tape it. Or if you're not using black paper, I guess we could just skip this step. is to put the box down so that the covering faces upward. So you're basically just sitting it on the table flat. And now this is when we're actually going to do the work. You're going to take the string, you're going to cut off a piece so it's just shorter than the box itself. So just a little
So where
bit.
do we tape the magnets? Where do we tape the magnets?
I'll tell you that later. Cut the string first. So you're going to cut the string so it's exactly the same length as the shoebox. Tie the string to one end of your paper clip. Okay, so now we're gonna tape the magnet on. So I'm gonna cut a little bit of tape.
Where do we tape the magnet?
Yeah, I'm coming to that. So see the side of this box over here, the top of this box? I'm gonna tape the magnet onto this. Magnet taped to one side of the box like this. Okay, yeah, that's great. So you have the magnet taped to the top of the box, and now you take your string and your paper clip, okay, and you tape that to the bottom of your box. You want to tape the string to the side that does not have the magnet. make sure that it's just barely not touching the magnets.
I'm done with this stuff.
Okay. So you've taped the string to the bottom and make sure that the paper clip is not touching the magnets, just a little bit off of between the magnets and
Well, but it just keeps going on to the magnet.
so you want to make sure it's just a little bit short of it. Then just move the string a little down, like pull it down more, use a little more tape to make sure that they're not touching.
Should it still be standing though?
Yeah.
How does it stand?
Right now for me it's touching the top, so I'm just gonna squeeze a little bit, just a little, so it's not touching anymore, and then for like a few seconds it'll just be floating there. I mean, it works better when it's flat because then there's less of a force. I don't know how well you can see it because we're online. See if it works better, like not standing up, because it worked better for me when it's like that. Move on. Yeah, and with the other paper clip you can do the same thing again on like another part of the box, but we don't really have time for that. So discussion questions. So how is gravity being defied in this activity? So can you tell me what's up?
The magnet pulls the paper clip toward it and it's stronger than the gravity.
Yeah, exactly. the force of the magnet, the gravity that the magnet attracts, the magnet's attracting the paperclip towards it, and that is stronger than the Earth's attraction on the paperclip, which is what keeps the paperclip floating. So in space, there's little gravity. So what do you think happens to objects or people in space?
They'll be floating around.
Correct. Perfect.